Hi everyone. In today's session, we will solve two problems. Firstly, we will solve a simple problem on the properties, that is radiation properties like absorptivity, reflectivity and transmissivity. And secondly, we will solve a very interesting problem on basics of radiation. We'll go to the first problem. The problem says 800 watts per meter square of radiant energy is incident upon a surface, out of which 300 watts per meter square is absorbed, 100 watts per meter square is reflected, and the remaining is transmitted through the surface. Calculate the following: absorptivity, reflectivity, and transmissivity. So it's a simple problem. What is given? Total radiant energy incident is given as 800 watts per meter square, and energy absorbed is 300, reflected energy is 100, and transmitted energy is the remaining, that is total energy 800 minus absorbed energy 300 minus reflected energy 100, that is 400 watts per meter square is the transmitted energy. Right, we have to find out alpha, rho and tau. So absorptivity alpha is always defined as the ratio of radiation absorbed to the total incident radiation. So radiation absorbed is given as 300 divided by total incident radiation 800. So alpha comes out to be 0.375. Similarly, you can calculate reflectivity. Rho is equal to radiation reflected divided by total incident radiation. So reflected energy is 100, total incident radiation is 800. So rho comes to be 0.125. Similarly, transmissivity tau is the ratio of radiation incident energy is 800. So tau comes to be 0.5. Here we have to be very careful. You can cross check. That is, the sum of alpha, rho and tau must be equal to 1. So 0.375 plus 0.125 plus 0.5 comes to be 1. So our calculation is correct. The next problem. Assuming the sun to be a black body emitting radiation at 6000 Kelvin at a mean distance of 12 into 10 power 10 from the earth. The diameter of the sun is 1.5 into 10 power 9 meters and that of the earth is 13.2 into 10 power 6 meters. Calculate the following: total energy emitted by the sun, energy received per meter square just outside the earth's atmosphere, and finally total energy received by the earth if no radiation is blocked by earth's atmosphere. Let us try to understand the problem. First thing is, we can assume the sun to be a black body, right? So given body is a black body and the sun's temperature is given as 6000 Kelvin. It is given an absolute temperature only, so you need not worry about converting that. Already it is in Kelvin only. Then mean distance from the earth, that is the distance from the sun to the earth is given. That is, here is the sun, okay, here is the sun and here is the earth. So the mean distance between the sun and earth is given as 12 into 10 power 10 meters. Okay, right. And then diameter of the sun is given as 1.5 into 10 power 9 meters. Then diameter of the earth is given as 13.2 into 10 power 6 meters. Clear? So two diameters and one mean distance is given, temperature is given. Right? Okay. So first we'll try to find the total energy emitted by the sun. Right. So before finding that, we'll calculate the emissive power of the sun. EB is equal to sigma into power 4. You know what is sigma, and T, you know, 6000 Kelvin. It's given in the problem. The substitute will get MSE power of the sun is 73.48 in 10 power 6 watts per meter square. But what we need to calculate is total energy, which is multiply this MSE power EB by the surface area of the sun. So sun is a sphere. So formula for a surface area is 4 pi r square. I am designating r as for sun's radius. Right? So 4 pi into diameter of the sun is 1.5 in 10 power 9. You divide it by 2, you will get radius whole square. So you will get 7.06 in 10 power 18 meters square. This is the area. Now you just multiply this area with the MSE power. Okay. So total energy emitted by the sun will be, this is the MSE power and this is area, right? So you will get 579.399 in 10 power 24 watts. This is the total amount of energy emitted by the sun. Correct? Second thing, emission received per meter square just outside the Earth's atmosphere. So it is an important concept you would understand. You please pay some attention to this. Again, this is the sun, Earth, and the main distance is given. Actually, in the previous subdivision, we calculate the total amount of energy produced by or emitted by the sun on the surface. That energy will be emanating from the sun. It will be coming out, and out. Always the energy produced is same only. So many watts, whatever we calculated, right? But when you come away from the sun, right, it is emanating in a spherical, in the radial direction. So when it comes to a distance of 12 in 10 power 10, that is near the Earth. So what happens? So if you draw a circle, keeping this as a radius, right? Radius, then on the surface of that invisible sphere, what will be the energy produced? That is what is called emission received per square meter just outside the Earth's atmosphere. Correct? Yes. So, AR is the surface area of the imaginary sphere whose radius is 10 into 12 power 10 meters. So 4 pi into r square, 12 into 10 power 10 square, will get, this is the area. This is the area of the invisible sphere. Right. Now, energy received per square meter is total energy produced by the sun divided by this surface area. Right. So 519.399 10 power 24 is the energy produced by the sun divided by this area. You will get 2871.19 watts per meter square. This is the energy received per unit surface area. So this is at the edge of the Earth's atmosphere. Clear? Okay. Now we have to calculate total energy received by the Earth if no radiation is blocked by the Earth's atmosphere. Now, in the previous step, we have calculated at the tip of the atmosphere amount of energy received per unit area, that is 2891.19 watts per meter square. Now, if we calculate the surface area of the Earth, and if you multiply that with this 2871.91, you will get total energy received by the Earth. So now let us calculate area of the Earth, 4 pi into RE square. So surface area we are calculating, and 13.2 in 10 power 6 meter is the diameter. You divide it by 2, you will get radius. So finally you will get surface area of the Earth is 5.474 in 10 power 4 meter square. Now total energy received by the Earth on its entire surface area is area of the Earth multiplied by the energy available per unit area at the outside. So I will get 5.474 10 power 14 into 2871.19. So the answer is 1.5717 into 10 power 80 watts. This is the total amount of solar energy the earth is receiving. Hope you understood, right? So you go through and solve it once yourself, and if you are stuck up, again go through the lecture and again try to solve it. If you have any doubts, you please contact me. We'll try to solve few more problems in the next lecture. Thank you.